Okay, so we'll be starting off with ancient Egypt. So the Egyptians had a very much so a need for math. So in a sense, they almost invented their own versions of math, and it's very similar to how we look at math today. So some of the things they needed math for was for buildings, calendars, taxes, measurement, and trade. So they had very practical needs for math. And so obviously two of the most practical applications for math are multiplication and division. And those are two things that we'll be looking at today of how they carried that out. So let's say we are given 25 times 32. How they would set this up in ancient Egypt was they would make two columns, and they would essentially double the columns, and you would have multiples of 32. And you would just keep on doubling it as you went down. So 32 becomes 64, 64 becomes 128, and in this column you have 1 becomes 2, 2 becomes 4. And so how they calculated this for multiplication is that they looked at the left column and they wanted to find numbers that summed up to 25. And so we look at this and we have 16 plus 8 plus 1 equals 25. And so now we look at the corresponding right column. So 16 corresponds with 512. So we have 512. And then 8 corresponds with 256. So we add 256. And then we have 1 corresponds with 32. So we add 32. And so if we sum all these numbers together, we get 800. And so we see that's the same value for up here. So that's how they did multiplication. So division was a very similar method. They, instead of looking at the left column and finding numbers that summed up, we looked at the right column. And so this time we want numbers that sum up to 532 because that's what we're trying to divide 19 by. And so we look at some numbers that add up to 532. We can look at 304, 152, and 76. That sums up to 532. We look at the corresponding columns, which is 16, 8, and 4, and you get 28. So 532 divided by 19 is 28. And so another interesting thing with division is that they actually had remainders and they knew a way to deal with that. So I found that very interesting. So now we'll be moving on to the Babylonians. So they had a base system of 60. So if you think about what that means, today we have a base system of 10. And so it's a little bit different than how we view it today. And they also needed it for very practical reasons. It was very similar to what the ancient Egyptians needed it for. The Babylonians needed it for accounting, taxes, land surveying, currency, trade, architecture, just basic things like that. Another interesting thing that the Babylonians were able to accomplish was they developed ways to find the square of a number. And it was actually pretty close to how we do it today, the values they got for it. Another thing they discovered was the Pythagorean triple. And down here below, I have two formulas for it. They were actually able to tell the difference between odd and even for it as well, which is quite impressive. Okay, so now we're moving on to Euclid. Now, Euclid, he mainly dealt with proofs and theorems and axioms. He didn't do many calculations, which is quite different from the first two things that we looked at with ancient Egypt and Babylonians. They had very practical reasons for math, and Euclid was kind of the first person to come out with more a proof-based math. And so Euclid wrote a book called The Elements, and two of his major concepts that you can see throughout it are geometry and number theory. Now, many people know Euclid for geometry, but not a lot of people know about number theory with Euclid. So we're going to go over some of his key discoveries and kind of summarize them very quickly. He came up with the parallel postulate, and this was a somewhat controversial topic at the time. It dealt with alternate angles. Another thing he came up with was proposition 628. This helped connect geometry and algebra and dealt with finding the area. Some things with number theory that he did was the greatest common divisor, the duplicate ratio, and he also showed infinite number of primes. Okay, so now we'll be dealing with Archimedes. He was from 287 to 212 BC. He did computations, so he dealt with actual numbers in math, which is somewhat different from how he viewed Euclid. He also worked in physics, And another interesting thing was he actually developed a method to compute pi. And so below here it shows the formula for it. And so as you go further down computing it and do more calculations, you actually get a closer approximation for pi. Okay, so now we're moving on to Apollonius. He dealt with conic sections. So essentially how this worked is you had a cone and you take a slice of it. So you take a plain slice out of it and you're able to get different shapes. And down here is just kind of some examples here below. I'm not going to go through it too much. Okay, so now we're moving on to Ptolemy. He did some major works with astronomy. One thing that he discovered was how the sun travels. He kind of determined that it travels almost in small circles, which was a quite new discovery. Another thing he did was he basically founded trig in a sense. And his trig was a little bit different from how we view it today. He dealt with more with chords in trig, whereas today we don't exactly view it that way. But it definitely helped set the foundation for trig. Some of the things he developed were the sum formula, the difference formula, and the half-angle formula. And these are, trig functions we still have today. So obviously it's stuck around somewhat. And he also created an accurate chord table, which is quite interesting. And so I'm now going to finish out with three last mathematicians, and they are Diphantus. He solved indeterminate equations with rational numbers. We also have Pius. He did several proofs with the method of assuming what is required and then exploring consequences, which in reality that's how we do proofs today still. We make an assumption and then we try and prove that assumption is true. And then the last mathematician we'll be looking at is Hypatia. She was the first basically documented mathematician that was a woman. And so that was very historic as well. And I think that is going to sum up our view of the first few chapters of History of Mathematics. Thank you very much.